Today we're looking at circumference. Circumference, talking about with circles. Circumference is the distance around a circle. That's not a straight line, so that's a little bit tricky, but they developed a formula to be able to figure this out pretty accurately. So this is page 441 in your book, but this is looking at the reference sheet for ISTEP. On the reference sheet for ISTEP, there are two different ways that they have listed this formula for the circumference of a circle. It's 2 pi r or pi times d. And you might say, well, how can we have two formulas for the same thing? Well, it's basically just depending on, am I given the radius or am I given the diameter? Okay, you'll notice the pi is in both of these formulas. Basically one has a d and one has a 2r. If we go back to thinking about a circle, there's different ways we can have a circle. That's not more of an oval there, but anyway, on a circle we could have something that goes halfway across the circle is called the radius. And then we could have something that goes all the way across the circle through the center is called the diameter. Well, if we think about it, we have a radius. If we would have another radius, that would be the same as the diameter. So basically, this formula, what they're doing is they're saying, well, 2 times the radius would be equivalent to the diameter. So it's just a matter of basically, you know, when you are working this out, did they give me the radius? Then you can use the one with the radius in it. Did they give me the diameter? Then you can use the one with the diameter in it, if you want to do it that way. Okay? Whichever way you want to do that's fine. And then the pi is a value that they've computed, which is approximately 3.14. The decimals actually keep going, they don't repeat themselves, but it's about 3.14. When we do this, when you guys are doing ISTEP, you'll be using the online calculators, and we'll get some practice on this. We'll check them out and see when we do our practice tests. But the calculators, your scientific calculators, you actually have pi buttons on. The ones on the computer probably are not going to have a pi button on it. So they'll probably say something about either they'll say use 3.14 for pi, or they might say write your answer in terms of pi. So we'll talk about those things as we go. But again, probably not be using the pi button on your calculators when you're actually doing this for ISTEP, although it's slightly more accurate than just using 3.14. So we look at page 442. We can start out, I guess, here with some definitions. We already talked about some of these, or all of these. So radius is the distance from the outside of the circle to the center. Diameter is the distance across the circle through the center. And then circumference is distance around the circle, going all the way around. It's kind of like the perimeter of a circle, you might say. It's just that it has a different formula because it's not a straight line. So we have to have a special way of getting that. And again, when we talk about circumference, circumference is pi times diameter, or circumference is 2 pi r. We talked about pi, it's the ratio of the circumference to the diameter. So basically, when these mathematicians thousands of years ago came up with this, they had to come up with this, by the way. It wasn't given to them like it is to you. They had to figure this out. So they just, you know, I guess took a lot of different measurements and things, different size circles, and they measured the distance around it, they measured the diameters. And the more and more they did this, the more accurate they were able to measure things. They were able to be more accurate or more precise with what this value of pi is. So no matter how big or how small our circle is, basically For example, if we have the diameter, circumference is pi times diameter. So if we take our diameter of our circle times a little more than 3, that would give us the distance around the circle. No matter how big or how small the circle is, that is always going to work. So if we go back to example 1, Mark recently replaced his front bicycle wheel. How far does the bike travel with each revolution of his new front wheel? So diameter of his bike is 26 inches. So we can use the formula that's given on your reference sheet that has diameter in it. So circumference is pi times diameter, so pi times 26. This part here, just like x times 26 is the same as 26x, similar idea here, pi times 26 is like 26 pi. So if you guys were ever doing a problem and they said, write your answer in terms of pi, that's what this would be referring to. This is in terms of pi. It means we just leave pi, we take the number, we leave the pi next to it, that's in terms of pi. Okay? So if we didn't have a calculator, that would just be a quick, rough idea of what our circumference is, which may not have really a whole lot of meaning to us, so we may want to actually work it out. So like I said, if we were otherwise using 3.14 is not too bad of an approximation. So if you multiply 26 times 3.14, you get 81 and 64 hundredths. So 81.64 inches approximately would be our circumference. Now, if you use the pi button on your calculator, you're going to get something slightly different. Pretty close to that.
68.
Okay. Pretty close, but a little bit more accurate actually than what this is. So you said 81 and
81.68.
okay. All right. So we're off by 4 hundredths of an inch. That's pretty close either way. Okay. Another application of this, somebody was asking about what's valuable about knowing with pi. We actually have, besides our Vex robotics, we have a Lego robotics kit that we've used in the past as well. And there's a thing about when you do the Lego robotics, you have to program it on the computer. So there's different ways of programming it. So when we first used the kit, we would program it based off of time. We would figure out, okay, I want the robot to go forward for 2 7/10 seconds. Then I want it to turn for 3/10 of a second. Then I want it to go forward for 1 5/10 seconds. Okay. The problem was the distance that the robot went depended on the battery level. In other words, if the batteries got worn out more, then it didn't go the right distance that we wanted it to go. So talking with another coach, they said, well, you can actually, rather than doing it that way, you can program it by rotations. How many rotations do you want the wheels to turn? So kind of working backwards in a way, you would figure out, take your distance and then take the circumference of the wheel and then divide those, and then that would tell you how many rotations you wanted it to go. And that proved to be more accurate than, depending on what our battery level being exactly the same when we ran the course. So look at the try it. What is the circumference of the rim of a basketball hoop with a radius of 9 inches? Okay, so the book talks about, multiply, find the diameter, then multiply that by 3.14. You guys actually have on your reference sheet 2 different formulas. So rather than doing that, if you want to, you can just go off of the formula that has the radius on it. Okay, so the one with the radius would be the 2 pi r formula. And again, if you want just an approximation, actually let's back up here for a minute. I'm going to leave that pi in just so we'll talk about writing it in terms of pi maybe again another time. And then our radius is 9. Okay, so if we were going to write our answer in terms of pi, basically we would just ignore the pi. We're going to kind of save the pi for dessert here. So these are all being multiplied. Commutative property we can rearrange, and we can go ahead and multiply 2 times 9, which is 18. So in terms of pi, the circumference would be 18 pi. All right, now if they want us to, let's say they said use 3.14 for pi, then we would substitute 3.14, and we could do 18 times 3.14. Oh. And again, this is approximate, it's not an exact answer, because this is rounding pi off a little bit.
56.52.
Good. So 56.52 inches is the circumference of the basketball rim. So look at example 2. Kayla and Theo got on a Ferris wheel, shown about how high will they be at the top of the Ferris wheel. So this is a rough approximation here. Circumference is 220 feet. So they know how far around this is. So this is a little bit different setup than what we've been doing. So this time we know the circumference. This is why if we get used to using formulas, that'll make things easier for you. So circumference is 220. We start by writing our formula and then just substitute. Circumference is 220. Pi, let's say, is 3.14. We're trying to find the diameter, because the diameter, the distance all the way across, that would be about how high they are up off the ground. Now obviously this Ferris wheel is not scraping the ground, so we would add a few feet for how many feet off the ground the Ferris wheel actually is. But anyway, then we'll just use our ideas that we've learned about solving equations. So if we're trying to figure out what d is, we can see it's 3.14d. So we can see those are next to each other, means they are multiplying, so we need to divide. Good. So we divide 220 by 3.14. So it's about 70. So they're saying they would be about 70 feet above the ground. And again, I would argue that maybe the ride itself is maybe 3-5 feet off the ground, something like that. You know, usually they may have a ramp going up to these things. So we may have to add on a little bit to that. But that's a rough approximation of how high they would be off the ground. You look at example 3. The larger gear turns twice per second. It causes the smaller gear to turn. How fast does the smaller gear turn per second? So larger one is twice per second, and then we're going to figure this out on the smaller one. So what we need to do is find the circumference, find how far it is around each one of these gears. So the larger gear has a diameter of 6, smaller gear has a diameter of 2. So they just substituted those into the formula. So the larger gear circumference is 18.84 inches about. Smaller gear is about 6.28 inches. And then if we divide that, that'll tell us how many times bigger the one is than the other. You divide that, you get 3. You can't always do it this way, but with gears we could actually do this based off their diameters. You could just say, well, the diameter of the one was 3 times as much as the other one. So it's going to, you know, be 3 times as many turns. So the larger gear is not going around as quickly because it's got a bigger circumference. So the smaller gear is actually turning around 3 times as many times per second. So 2 times per second for the big gear. The smaller gear is 3 times that, would be 6 turns per second. Okay, we'll look at the try it. Circle has a circumference of 9.42 units. What is the area of the square? Use 3.14 for pi. Explain how you found the answer. So to start out with here, we know the circumference. So one option we could use our formula, circumference is pi times diameter. If we just go ahead and put a 3.14 in place of pi. So from this formula, this is not going to get us the answer right off the bat here, but this is going to get us closer. They're multiplying, so we can divide. So if we divide that, we'll get 3. So that means the diameter is 3. Well, if we look at our green lines over here, the green lines actually inside the circle, rather than the diameter, those represent the radius. Okay, so the radius is half of that. So if the diameter is 3, if we take half of that, means our radius would be 1.5 or 1.5. Good. So that would be the radius. And then, as someone said, we've got the length times width to get the area. So length and width on the square are both 1.5. So we could take 1.5 times 1.5. And that would be 2.25. They didn't tell us if this is inches or what, so we'd say 2.25 square units. So again, just working with trying to be comfortable using those formulas. Write your formula, substitute into your formula, neatly showing your work, showing your steps. That'll make it easier for you to see what to do on these problems. So key concept, just kind of recapping the different things we talked about. One thing I didn't mention earlier, sometimes instead of 3.14, 22 sevenths is another value that kind of approximates pi as well. So you can use either one of those. 3.14 is pretty commonly used though. So we look at the do you know how. Number 4, what's the circumference of a circle with a radius of 5 inches? Once again, we've got two different formulas you can use for circumference. We've got one that involves the diameter, one that involves the radius. So this time they've told us the radius is 5 inches, so it might be easier if we use the one that involves radius. Yes. Okay, since we already have the radius. If you don't want to, if you want to just always use the diameter one, that's fine. So basically, I'm sorry I didn't start with my formula here. This is 2 pi r, and then the radius is 5, so I'm just substituting that. Now, if we were writing this in terms of pi, we can multiply our numbers together. So 2 times 5 is 10. So that'd be 10 pi in terms of pi. And then if we wanted to actually get an approximation here, we could use 3.14. I don't really need a calculator for this because I know if I multiply by 10, my decimal is just going to move one spot to the right. So this would be about 31.4 inches. Circumference is just regular units because it's a distance around something. So it's 31.4 inches would be our circumference. Number 5, they're wanting us to find the diameter of a circle with a circumference of 10 and 99/100 feet. So again, we have two options for our formula on your reference sheet there. This time we can use the one that involves diameter since we're trying to find diameter. So we could do the C equals pi times d. And this time, which piece of information did they tell us? Circumference. So in place of the C, we'll put the 10 and 99 hundredths. Again, just approximating here, we can put a 3.14 in place of pi. And then solving for pi, we would need to divide by 3.14. Good. So when you divide that, you get 3 5/10 or 3.5 feet would be our diameter of our circle. And we look at number 6. How many full revolutions does a car tire with a diameter of 25 inches make when the car travels 1 mile? So this one we have a little bit of converting that we'll need to do. So first of all, we could figure out what the circumference of the tire is. Circumference of the tire, that's the distance around the tire. That would tell us 1 revolution how far the car would go. And this one we know the radius or the diameter, so we could use that. Circumference is pi times the diameter. So again, we'll just say 3.14, diameter is 25. So that tells us for 1 revolution, each time the wheel turns all the way around, it's going 78.5 inches. The next thing, we're going to have to do some converting. So we have 1 mile. 1 mile, if you look on your reference sheet, is equal to 5,280 feet. Good. And we know that 1 foot is equal to 12 inches. So if we take 5,280 times 12, that'll tell us how many inches we have in a mile. So 63,360 inches in a mile is what that's telling us. So that's how many inches we've got to go. We know 1 revolution is 78.5, so then to figure out how many revolutions we just need to multiply. So we're going to take and divide these. So 63,360 divided by 78.5. In other words, how many 78.5s do I have till I get to 63,360? Okay, we know our answer has to be less than 63,360 because the wheel is going more than 1 inch for each revolution. So if you try to multiply or add or something like that, that's not going to work because we need our answer to be smaller than the number of inches that there are in a mile. Okay, so we divide that out.
The other numbers would be 3, 7, and 8.
Alright, so this roughly comes out to 807 revolutions. It's not exact. We could take, with your calculators, you could actually get that as a mixed number answer, but this is pretty close, probably close enough for what we're doing here. 807 revolutions.